Introduced. I'm Gideon Lerman. I'm managing, and I will talk a little bit about the company, the Lerman Architects, and the natural gas discoveries in the Levant Basin, local and regional petroleum industries that are developed, the domestic demand and exports, and spatial dimensions of the production and transportation infrastructure. Lerman Architects was established in the 70s. Our expertise is master planning, spatial planning, infrastructure planning, the strategic development. We are firms that expertise in consulting to government agencies, government ministries, World Bank, infrastructure development agencies, real estate developers, municipalities, NGO and industry. We deal with the strategic plan from the place of the idea and how to take the idea and to physically promote it to show that it's becoming a reality on the ground. And we also deal with architecture. And the firm was established by my parents, who are architects, and they deal with architecture and with structural planning for many years. You can see some of the projects we were dealing. Some of the projects we're dealing is developing of airports, like the Ben Gurion Airport, the ports, like the port of Ashdod and the industrial area behind it. I was recently managing a project of the World Bank in Albania for developing strategic development, investment plan, and statutory planning for 4 municipalities. We have a development policy for the Dead Sea area. We made a big project on artificial islands on offshore Israel. And recently, of course, the gas discoveries in Israel, and we are managing a multidisciplinary team in this field. As we see, you see several of our projects. As architects, we also design industrial parks, hospital, etc. I'll talk a little bit about the Levant Basin. Recently discovered, the USGS has discovered that in the Levant Basin there's about 122 TCF of natural gas. This is the recoverable deposits that are around this area. Majority is in Israel, some of it in Cyprus and in Lebanon. In the vicinity, we have to remember that there is another basin with proven reserves in Egypt, which is much larger, and 2 other basins, one entirely in the economic zone of Cyprus, which has not been explored yet, and the Mediterranean Ridge Assessment Unit, which has not been explored as well. What we see is that all this area that is between Cyprus, Egypt, and Israel, there's lots of gas deposits recently discovered. There's proven deposits both in Egypt and in Israel, and some discoveries even declared in the Cyprus economic zone, Cypriot economic zone. The main characteristics of the gas in the Levant Basin, not in other basins, is that it's ultra deep water wells. Most of them, as you see, Tamar is about 1,700 meters deep well of natural gas. If you remember the Macondo in the Gulf of Mexico, which is an oil well, it's basically the same depth. And this is a very complex engineering challenge to utilize the gas that is coming from this deep water. You need a subsea completion, which is a system that is underground, built by robots to use the wellheads and the manifolds that are taking the gas from the wells to the processing units elsewhere, which are tieback, being located far away from the wellheads. High pressure of the natural gas and high temperature requires some management, because it's difficult to reach this high pressure to bring it to the shoreline. This high pressure is becoming lower and lower in the future, in a few years, because the reservoir starts to deplete. But in the beginning, we're talking about very high pressure. Capital investment in the beginning is quite high, which is another remarkable character of these discoveries. And the good thing about this discovery is that it's quite a good quality gas. From what we know from the gas composition of the Leviathan and from Mary B and Tamar, it's very good quality gas. What we mean is that there's low percentage of carbon dioxide, low percentage of CO2, and the gas is considered as dry and sweet, which is a good sign for gas. The gas reserves are very, very big, and they exceed long-term domestic demand, both in Israel, Egypt, and Cyprus. These three countries don't need so much gas. The gas, basically, if we're talking an analogous field, Norway is a good example. Norway doesn't use gas for domestic demand. All the gas that it's exploiting is for export. All their energy is coming from hydroelectrical power, so it's a nice example. The gas is in deep water in the subsea completion, then it goes to a facility which is onshore, and from there gas is exported by a pipeline to England and to the European grid. This is the processing facility on Nyhamna in the center of Norway on the coastline. And this is the structure of how it looks like. This is also a characteristic structure of how this system is being developed downstream and upstream and downstream. What we call is the subsea completion, which is the wellheads. This is in Philippines, but it's the basic structure. Then you have some from the manifolds, which you saw the pictures earlier. You have some pipelines that going to some kind of a processing facility. Then to finish the processing, which is usually made onshore. From there, it's going to the consumers. In the case of the Philippines, it's domestic consumers, electricity and alternative fuel. This is an example from Teddletop in the UK. This is one of the receiving stations for ConocoPhillips gas deposits, which are in shallow water in the sea, and also it receives gas from Norway, from Norwegian wells. There's several concessionaires in one area. It's close to the sea. You can also see old routes of pipelines, which has been done with less environmental consideration. The new routes, you actually don't see them, but this is connected to this area. What is the processing facility is doing? Separating the natural gas from the water and the condensate that are coming along with it. It's a very simple method of treating the gas, which is dehydrating the gas by cooling and heating and recooling and reheating for the sales specification of the domestic demand. Offshore, we have lots of examples of how to process the gas. Drilling facilities or processing facilities are being located on platforms, which can be floating platforms or platforms that are connected to the sea. Mary B, for example, in Israel is this kind of a platform. In the Gulf of Mexico, many of the platforms are in deep water or ultra deep water and used for drilling. For the drilling process are like this, which is TLP or spar, made for deep water and anchored. Some of the shallow water is by a jacket that is standing on solid ground. So this is all kinds of facilities that can be used offshore for processing. This is an example for a development of a field for export, a classical example, which is in Pluto in Australia. Australians are exporting to the Far East, which is the highest price. They pay the most high prices for the natural gas, and they have LNG facilities. You see the wellheads and the manifolds on the offshore. They come to a riser platform, and from there is connected to the LNG and gas processing facilities that are becoming onshore. You can see it on the map, basically where it is. It's quite a large development. The industry in the eastern basin of the Mediterranean is composed of several companies. Here you see the Cyprus and the blocks that are being explored in the area of the economic zone of Cyprus. Also, of course, Israel. Noble Energy is one of the main companies that are extracting gas. They have Delek, Avner, Ratio. You hear other companies, but major companies. Noble Energy. Egypt, you have the shale oil, which was also involved, I think, sometime in Cyprus in the past, and BP and other companies that are working in the Egyptian offshore industry of gas. The domestic demand, which is one of the needs. Most of the countries use the natural gas for domestic demand. They need it first for power generation. I think also Cyprus thinks that they need it for power generation. The industry, if there is some industry that wants to use the gas, it's much cheaper than to use electricity or for steam or other uses. They use the natural gas. Also, natural gas can be converted to methanol and to DMT, other materials that are very efficient for good industry, and it can be used for transport. The CNG can be used for private cars. In many countries it's being used for private cars, and it can be another demand in the domestic market. In northern countries they use the natural gas for heating. Every house is connected to a natural gas pipeline in the Netherlands, in Canada, and parts of the UK and the US. But I don't think that this is the case in Israel or in Cyprus, that it's relevant, because it's mainly for heating. The development for the domestic demand requires a transmission system to transmit the gas from the processing facilities to the throughout the country, so the demand can be spread along the country, and the distribution system that connects the transmission system to the customers in lower pressure of gas. The receiving stations are the stations that process the gas, as I showed you before. As in Israel and in Cyprus, the meaning of the recent discoveries is a fundamental change of the fundamental spatial change of the planning system and the planning development that we are known today. There's infrastructure for water, for electricity, for roads, but not for natural gas, which is hazardous material and has to be considered as such when you develop such a network. And it has its own implication on the actual planning in every area. Actually, the planning today is not correspond with the needs and requirements of the natural gas, and it's a major issue of consideration when you have a planning process. So what we have is large corridors of the transmission system, flow assuring facilities. You need to keep the pressure. It's other facilities that you need to find land for them and to see what are the other uses around it, so there will not be some risk to the other adjacent uses. Also facilities for reliability and redundancy. Natural gas is not unlike diesel fuel or coal that you can store very easily. It's much more complicated to store natural gas for the domestic market. And also storage facilities that are usually underground on all the natural gas or oil deposits, and can be used as storage facilities that you pump in the gas into, so you can use them when you choose. Process facilities can be partly offshore. Then now I'll talk about the Israeli example. Usually process facilities that take the gas and utilize it, as I showed you before, are done onshore. In Israel, because of public reaction to the ability, to the attempt of Noble Energy to process the gas onshore, the government decided to explore the ability to process the gas offshore. And this is the project that I'm managing. The natural gas transmission system in Israel is as follows. Gas is coming either from Egypt today by a company called EMG, and from the Maribi platform that is managed by Noble Energy basically in the maritime border between Israel and Gaza. This is the two discoveries that are actively, since 2004, are connected to the Israeli transmission network. Some of it is existing, the one that is marked in yellow. Some of it is planned and under construction under these days. There's about 400 kilometers of transmission system. It's a high pressure system on 80 bars. Some of it offshore, some of it onshore. And from it, there are some stations of the power stations that take the gas to use for electricity, and some pressure reduction systems to connect to the industry and to other uses. The plan that we are doing is to see other additional 2 entry points, like the existing one in Ashdod and Ashkelon, in the northern area. Because of the length of the system and the length of the Israeli state, we need to put a parallel ability in the northern area of the country to supply reliable and available gas for long term. The aim of the plan is to provide for the next 30 years of a reliable and steady supply of natural gas for the domestic market. The planning team that I'm managing is a very large and multidisciplinary team that is composed of international consulting firms and local consulting firms on various issues, from the engineering aspects to the environmental aspects, that we are doing an environmental impact assessment, of course, of the project, strategic environmental assessment, and also we have some PR and public participation experts as well. The conditions that we used for the planning is that we are controlling the pressure offshore because it's a high pressure. We're controlling the pressure offshore because of the public outcry of trying to bring the high pressure gas to the shore, which is the main risk factor in the natural gas treatment. We're talking about a very high capacity of gas facilities, gas processing facility, capacity of 2 million cubic meters an hour. It's a very high capacity. It's about 48 million cubic meters a day. It's roughly some of the largest treatment facilities in the world of this capacity. So we're planning for this capacity as an upper threshold for the planning the development in Israel. We're looking at a plan that will deal also with current concessionaires that are exploring and drilling offshore the Israel and future concessioners. So everyone that will find gas and will try to utilize it in the next 30 years will have an answer from a statutory point of view of where to put the facilities, how to connect them with pipelines, and how to distribute for the domestic market. We're talking about 2 separate facilities for this kind of capacity. And I will show you basically what we're talking about. There's 2 separate facilities. Each one of them is for more than one concessionaire. This is an example of this orders of magnitude of a processing facility, which is in the Netherlands, which they have a lot of experience in dealing with gas. This is one processing facility, one location with 3 different processing facilities. The ones that in red, blue, or green are communal processing, and the parts that are yellow are, the ones that in red and green and blue are each company has developed for its own, and the yellow ones are communal facilities for part of the processing, offices, parking, the power station as well, but the service center when you are meant to fix things, and the flare area. You need a flare area to vent the gas if you need to, if you have some emergency case. Then you have this storage of condensate. Condensate is a kind of a diesel oil, it looks like diesel oil that comes with the gas. It comes in the case of Leviathan and Tamar, it comes in pretty high quantities, and it's an essential part to use and to store this. The condensate is an essential part of processing the gas, because if you don't have enough storage facility for this condensate and you cannot market it to the industry, then you have to stop processing the gas because you can't utilize it. The plan will supply the treatment for all the pipeable products. It's coming also for produced water. The gas is coming with the water, and you have to dispose of the water. And the amount of condensate, as I said, it can be pretty high. It's about 100,000 barrels a month for this facility. That's quite a lot. This is examples of the facilities we are planning offshore and onshore. The facility can plant entirely onshore. However, because of the public outcry and the density in Israel, we are looking at offshore options for processing. It's quite unique. Most of the countries, if they do offshore processing, it's from economic point of view only, and not from because of pressures from the public. In Israel, the situation is different. Israel is not the only country who is doing this, but this is a solution that is chosen for Israel. So we made this solution as a schematic outlook. There are the gas discoveries, for example, Tamar or Dalit, which is a much smaller field, which are located far from the territorial water in Israel. The legislation system in Israel differentiates between the territorial water and the economic exclusion zone, which are 2 different legal entities. So we deal only in the plan in the area which is within the territorial water. Every concessionaire who finds some gas can be connected with the corridor to the facilities which are offshore and can do partial treatment. And from these facilities, we will go onshore to complete the treatment in a most reliable way in certain designated areas. This area that is onshore
because it's partial processing, doesn't necessarily has to be on the shoreline. It can be even 10 kilometers east of the shoreline, even more. The question is if you find the right corridor to put all the pipelines between the coastline and the facility inland, and it's possible. It's not possible in the case of LNG, but on processing of gas for domestic use, it is possible. We looked at several alternatives of locations. One of the issues that the residents consider very much highly, and as I said, this plan was originally made by Noble Energy, and because of the public outcry, the government took it under its responsibility, and I was nominated to manage this plan. So the first thing we did is start evaluating other options. If not the ones that Noble has selected are not the best, maybe other options. So we start looking and eliminating options which are suitable for gas processing facilities all over Israel. You see, we tried to look about 25. Now we reached downsize it for 4 that are going for the environmental impact assessment. However, we started with 25 facilities. We didn't say that there's one facility which is the best, because from a judicial point of view, the court ruling is that the plan has to consider alternatives. And this is an important issue, and that's why the court was supporting the residents against the development of that made by Noble Energy. So we looked at several facilities, then we start an offshore consideration. It's not simple at all to put offshore structures. You have to see if the soil is stable enough. In the coastline of Israel, the Levant Basin is not stable. What is happening? There is the salt layer. The gas is basically was condensed beneath a salt layer that holds it to be not to and hold it as deposits. All the deposits that we're talking about in the Levant Basin are pre-salt deposits, which are under a salt layer that is underground. This salt layer can be pretty thick. I think in Leviathan it's about 1 kilometer thick of a salt layer. Also, the oil in the world is usually found beneath the soil, beneath the salt. So the salt is the material that makes it that sealed the ground millions of years ago and doesn't let the gas to evade to the atmosphere. However, from the time that the salt layer was developed, afterwards there was clay layers and sand layers that are become that was laid on the soil, and these layers are sliding all the time. It's becoming more and more deep in the areas that are more and more deep. We can see this here. All these slides. This is the area next to Ashdod. This is the area. This is Haifa. So this is the area you see. And we can see the landslides coming closer and closer to the shore. So putting a facility on, putting a platform on 4 legs on an area that is next to these slides will make it fall down in the first earthquake, like we saw 3 days ago. It can fall down, and it's a very challenging engineering. It's a very challenging engineering issue, how to locate these facilities, and now we are doing a detailed study of the area that is between the landslides and between the shore to see what is the optimal areas to locate these facilities. It's all because we don't want to locate it onshore. This is for the domestic use. We made a map of areas that are more risky. You see them in red, and in yellow less risky, and of course close to the shore it's much less risky for putting gas facilities. However, the gas processing facilities are quite big, and they need some safety distance between them and other offshore excursions like sailing or maritime paths. So you don't want to put them next to the shoreline. You want to put some sufficient distance between the shoreline and the facilities. That's why we were looking at several areas which are about 7.5 kilometers from the shore, and not in the area that you saw before marked in red, which is a dangerous area for facilities, for offshore facilities. And we were selecting several facilities, several areas for more detailed evaluation. If it's possible, we will select finally 2 of the 4 sites that are mentioned in this area as sites for the offshore facilities. This is the main delay of this project today in Israel, is to find if these areas are suitable to withhold offshore processing facilities. It's a small artificial island that is weighed quite a lot. This is a map of how you put these facilities, how you connect to them with pipelines. from the facility to the shoreline. So this is the areas that we are considering now on offshore. If we're talking about export, export is more complicated than domestic use. You have to explain that you need to export it. But you have to understand what is the decisions, what are the conditions to export. This is the tzemach community that in Israel that makes the conditions, what is allowed to export, under what conditions. Not everything is exported in Israel. I'm talking about the Israeli point of view. Some is exported. Some of the gas will be used for the domestic market. The tzemach committee says that you have to assure that the domestic demands will be answered for a long term before you can start developing the schemes for exporting natural gas. Exporting always have some effects with the domestic market. Either, like in Egypt, the export is from the domestic market. The gas, the transmission system, it provided Israel with gas. Not now, but until a year and a half ago, it provided Israel with gas. Basically, Israel was connected to the transmission system, the Egyptian transmission system. Another issue is small field policy. It's not an issue that is dealt directly today in Israel, but in the Netherlands, in Norway, in other countries, it's a very important issue. If you find a big field, it's very profitable to go and export. But what happens with the concessionaires who find a small field? It's ultra deep water, high capex, and you need to find how to utilize the small fields and not to give them up, because 6 or 7 small fields are like one big field. And if we look at the Gulf of Mexico, the Northern Sea, or the Western Africa examples, or Australia, after you find some big fields, you find quite a lot of small fields. Today in England, they find only small fields, half TCF, 1 TCF. This is the size of most of the fields. And for the last 20 years, this is the sizes of most of the fields discovered in the Northern Sea, outside, except in Norway, which is one exception that finds bigger fields. So there's a need how to exploit it. In the Netherlands, they give the priority to utilize the gas and to put it into European grid. There, the attitude for exporting is a little bit different. And they want to assure that the gas from the small fields are being utilized and these deposits are being exploited in a good manner, so they don't lose the revenues and the income on a national level. Another issue is to identify the main customers. The main customers can be far away, then you use LNG. If they're close, like Israel was with Egypt, then you can use a pipeline. It's different considerations. And another thing, which is my job mainly, allocation of the facilities in the infrastructure. It's not an easy task at all to allocate these facilities and infrastructure. Export can be done mainly in 3 ways: pipelines, CNG, which is compressed natural gas, and LNG, which is liquefied natural gas. Pipelines are, as you know, just pipelines coming from one place to another. LNG and CNG are exported by ships. Pipelines are the cheapest method of exporting. When you have a route, if you find a route and you find a customer, it's the cheapest way to exporting. And you can export it directly from the transmission system, the local transmission system. You just need some compressors and you export the gas. Then you have to see if the area is suitable for using this gas. If you export by pipeline, you increase the reliability and the redundancy of the domestic transmission system, because you don't have issues like swing and other issues that are controlling the domestic market and are affecting the prices of the development of the facilities for flow assurance. Requires a feasible offshore routes. If we're talking about Israel, to export to Greece or to Europe, it's very difficult because the water depth is too high for putting today pipelines. And if there will be a pipeline, it has to be either inland, then we have to make peace with our neighbors, impossible. And offshore, we have to agree with, I think, with the Turkish government to do it. Also looks like quite impossible. I'm talking from the Israeli point of view. I don't know enough about the Cyprian point of view. Of course, the processing facilities that used to process the gas has to be considerably larger, and there will be some compression facilities. Compression facilities are the most expensive facilities in the life cycle of natural gas deposits. They use a lot of energy, and they have to be changed from time to time, and they are quite costly. However, pipelines are relatively cheap to pipeline system for export is the cheapest way of exporting gas from the other possibilities. Another possibility is CNG, is compressed natural gas. You compress the natural gas to ships. You can do it from the transmission system with the right compressors. You need a loading port. You have to find to connect the boat that takes the gas from the pipeline, from the compressors. And you need approximate customers. There's a very important issue. You cannot sell the gas for long distances. It requires some proximate customers. It's cheaper than LNG. Development is much cheaper than LNG. When you're talking about small quantities of natural gas, you can use the compressed natural gas as an alternative. Basically, it's a very long pipeline. This is a system. The compressed natural gas as export was never used before. Mainly compressed natural gas is used for transportation systems. Cars are taking the natural gas in a pressure of 250 bars, which is much higher than the transmission system. However, you can take the processed gas and put it in some kind of magazines like this. These magazines are inside the ship, a very normal tanker, which is it's not different than any normal tanker. It can be built. And they can be a processing facility even offshore to process the facility. And the company that I met that say that they can do this, and I heard several companies who can do this, gave the costs of the transportation for 1 million BTU. 350 kilometers is about $1.46 per million BTU. As I said, they never tried it, but they develop it to a structure that they can be developed. They have a DNV assurance that they can develop this, so the banks can finance these projects as feasible. What is important to understand about CNG, that it can be used by a floating production vessel, can be used, converted to FCNG. It's compressed into a pipeline. As I said, it's a pipeline, and it's less sensitive to the quantities. LNG has to be processed to a very high level of a clean gas. Has no other materials inside, no water, no condensate, also no CO2, mercury, or other materials like carbon dioxide. With the compressed natural gas, you don't have to get to the same level, and then the treatment is much cheaper. This operator that I met says that the transfer operation can be done in the offshore, so the compression facilities can be done offshore, but this is a not proven fact. They just engineered like this. And doesn't require a large gas storage like the LNG storage facilities to put the gas that waits for the ships. It can be managed and planned in a way that there's no large storage facilities. And the vessels that are using this can bring LPG or CO2 for other uses, can be used in the same transport system. LNG, which is the most known method of exporting natural gas, has high capex, more capital intensive investment, even before the construction. So the issue is considered very suspiciously by financing bodies if you can do LNG or cannot do LNG. The best thing to remember is economies of scale. You need a lot of deposits of gas that are around an LNG facility to make it feasible. The facilities are located on the coastline. You need an offloading ship or an onloading ship when you're at a receiving station, but the facilities are located on the coastline. You don't have the benefit like in processing facility to put it far away from the shoreline. In Israel, it's a big issue because there are hardly any vacant land on the coastline. The market or the companies that build LNG facilities are highly conservative. They are very suspicious on geopolitical issues, and also when you're dealing with deep water these deposits, they take it very suspiciously if it's possible to develop these LNG facilities in an economically feasible way, because the cost of extracting the gas from the sea and treating it with an LNG facility in all total can be quite costly if you compare it to Qatar or to other countries that have the gas on shallow water and have large facilities for exporting, just for an example. And we need a gas storage facility. These facilities are quite big, comparing to processing facility. This is one in Malaysia. This is an export facility in Malaysia. It's quite big. You see the ship. This is the size of the ship. These are the tankers for the LNG. These additional tankers, and this is the processing gas facility that is surrounded. It's in Japan. They managed to develop the LNG facilities for, in Japan it's used for import, but they managed a tanker holding system which is unburied. That's buried tankers. You can have a much safer facility for storage of the LNG, and you can be with other land use much more proximate. When you have something like in Malaysia, in this area, you have to make the facilities around it much more distant. The challenges for the domestic demand that we learned about it, you need specific rules and regulations to assure sustainable development of the natural gas market. The risk issues has to be dealt with. It's a very important issue when you're dealing with the public, and in a democratic country it's a highly important issue. Also the other issues of how to combine the other developments like power generation and other developments with the development of the natural gas infrastructure. Strategic planning and spatial planning are essential for the success of this process. Israel has failed with using the gas that is discovered mainly because it didn't have the strategical planning and spatial planning. That's why they hired me, because it wasn't available beforehand. And this was the main criticism of the courts on the Israeli government when they tried to let Noble develop its facilities on shore. The best thing is not to hide this development from the public. The public reacts very aggressively to the idea of natural gas, not only in Israel. I will show some examples. And it's very important to explain why it's good to deliver natural gas. I'm talking about the domestic market. The industry also has to understand why it's profitable for them to use natural gas for its own needs. And as I said, the safety issues are essential also in domestic and also in export. This is the backbone of the development. If you don't deal with the safety issues very carefully, then there's no project, basically, as much as we learned in Israel, and not only in Israel. Establishing a local government commitment is also essential. In the end, you have a facility in some local council or a municipality, and the municipality has to understand what are the benefits that they are going to see from this facility, which is serving the nation in a whole, and not the local council in particular. The main issue is NIMBY. This is an example of a gas processing facility in Ireland. The gas processing facility was built 9 years ago, and it's still not connected to the shoreline. It's 9 kilometers from the shore. These huge demonstrations, people will get arrested, and this is quite a derelict area. However, the people in this area, I'm talking about 2009, 2010, after the economic recession, everybody understands in Ireland that there is a lot of economic benefits from using the natural gas for the domestic use. Shell, which is one of the biggest companies in the world, has tried to develop it, and for 9 years they don't manage to connect this facility to the shore because of the public protest in the area. Same thing happens in Israel with the project. I'm responsible all the time. Every planning meeting that we have, there's demonstrations outside of people who are very much concerned from the possible problems. This is why also the Israeli government is reluctant to deal with the issue of exporting gas. This issue, the team that was here was against Noble Energy's project, and now they're fighting against the project I'm promoting, and they have direct access to ministers, to parliament members. They affect their opinion, and then we have to follow them up, and everyone they meet, we have to meet them again to convince how important it is for the government. But on the local government basis, every mayor or every municipal council head of municipal council is sure that if he allow or collaborate with us or allow the facilities to be developed in his vicinity, he will not be re-elected, and they are certain about this issue. That's why it's very difficult. The challenges for exporting are much higher because then it's not for the domestic market. It's not for cheap. It's not that you can tell the people that it's going to be cheaper for them the price of the electricity. You have to explain why and how they profit from the export. And then the issue of how to allocate the right area for the facilities have to take this consideration. If there was a right explanation, if this was explained well or not, it's one of the issues that the planning process has to be taken into consideration. For me, in my experience, local councils and areas that Nobel has tried to develop the facilities in their areas are much more hostile to me and to the development than other local councils that I introduced the idea of putting processing facilities within them. Talking about adjacent local councils, I was looking for alternatives. The ones that we approached in the beginning, and we told them that we want to consult with them about their ability, are much less hostile than the ones that were feeling that Nobel and the government were trying to impose on them gas processing facility. About LNG, there was an attempt in Hadera to use LNG facility. The municipality and the residents went to the Supreme Court. One of the arguments was that the risk from an LNG export facility is much higher than from an atomic bomb. This is taken from the papers that were submitted to the court about this facility. This was published in all the newspapers, that LNG facility is much riskier. This is hilarious. If you're talking about, this is a quantitative risk assessment that was made in Rotterdam in 2006 about LNG. They use it for import, but it's the same thing. This is a peak shaving facility that they developed in Rotterdam. The Netherlands has lots of gas. However, they decided to develop LNG facilities for import for the future and for controlling the swing, which is a very important issue from an engineering point of view. So they developed this area. Here you see the risk contours of 10 to minus 6 for individual risk is the red one, and this for communal risk is this one. And you see this in the port of Rotterdam. This area, 2.5 kilometers from this area, there is a town, a small town, which is not so much afraid of this development as it is seen in Israel. So if you're looking at the Netherlands, when they had a lot of mitigation with the public and explanation of the ideas of the risk, then this attitude will be convinced in the public, will be perceived in the public as hilarious. In Israel, if somebody sees this and he lives next to the area that they want to build an energy facility, they will panic and they will do whatever they can do to avoid this development to happen. And this is the main issue why the LNG facilities are not developed in Israel. And this is because the Israeli government made a mistake and went to plan the facilities before they went to talk to the public. And before they tried to explain how they're going to deal with the emergency cases, they didn't make a contingency plan. They didn't explain the contingency plan to the public. And that's why the public came with these ideas to the Supreme Court. And it's very difficult for a judge to go and to decide if to develop something in this area when this kind of picture is displayed to him. And this is only for an LNG tanker, not a storage facility. So, in the reality, this is the LNG tanker. This is the size of an LNG tanker. So you see that the size and the contours are much, much smaller. They exist. And they have to be taken care of very carefully. But it's a different story than the public outcry. So in the conclusion, immediate identification of stakeholders is essential for the success of the plan. Stakeholders is not only the public. It can be government agencies. It can be other stakeholders. I hear that in Cyprus the church has a lot of land. It's definitely a stakeholder. Property issues here are dealt very carefully, as I saw in the plane in the brochures that everybody reads in the planes. Government entities should be committed to the success of the development and understand its necessity. It's another thing. If the Ministry of Labor will say that there are, or whoever is responsible for the safety will say that this is dangerous, then the Ministry of the economic ministries that try to promote this facility will not be able to promote it. So first the government has to agree that what is the set of rules and guidelines to develop it, and then to go to develop it and show it outside. It's another issue and a precondition for success of fast, rapid development. As I said, the natural gas discoveries are a great opportunity, but needs a careful and considerate planning that are essential for the development of a healthy natural gas market that serves both domestic and international customers. And this is the end of my presentation. So thank you very much.